Hello, folks. Welcome to Rational Science. I'm a little late today because I've been coughing my brains out. I hope everybody can hear me fine. Let me know, please, in the comment section. I appreciate anyone telling me. Yeah, I've been coughing all week trying to get rid of this stuff, and no luck so far. Anyways, we're going to be doing some questions today. Lots of people ask questions, especially since I started my shorts series, physics shorts. And then I'm going to be doing the main course, which is mass, gravity, black holes especially. And finally, there were so many questions related to magnetism. People want to know what magnetism is. They believe they know what it is. None of a little bit about magnetism as well at the end. Okay, so let's get started. We have one fellow here, and he says, again, let me know if everybody can hear me fine out there. Okay. One fellow says the following. He says, the more fields you have, the more crops you can grow. The good news is we'll never run out of food. And I say to that, famous last words, I think it should be in the list of famous last words. Extinction is going to come. It's going to come for sure. And it's going to come because we're going to run out of food. Why are we going to run out of food? Because we produce food artificially. We no longer do it the Mother Nature way, whatever we find out there in the fields or, among animals that we kill. Okay, thank you. So what's really happening out there is that we're making our own food, but we're making it only because of money. We have this abstraction called money. We pass it around, and thanks to that, we all eat, and thanks to that, we all work. Thanks to that, we all pay taxes and tariffs and who knows what else. But imagine you wouldn't receive money for whatever reason. You lost faith in money. In God we don't trust anymore. And what happens at that point? Well, at that point, the whole global economy collapses in one second. Okay, a picosecond. And what happens? Suddenly, no problem if the money collapses. Right, disappears. Nobody wants it anymore. But what about the people who produce food? They produce food only for money, and they will not produce it or distribute it, the distributors, to your home or to your local area, your supermarket. And now we're all out of food. And where are we all? Primarily in the big cities. We all depend on supermarkets. We all depend on someone to bring the food to the supermarket by some miracle. All is that you go to the shelf and there it is, whatever you want. And imagine it's not there anymore, like in Cuba. I've been to Cuba, and let me tell you, it's a weird world, different kind of world. Anyways, moving on here, some more questions here. A fellow says, exist. He wants to define it, right? So to exist means to have what? Objective reality. Okay? Or presence in the physical world. If he would have stuck with presence in the physical world, he would have been just fine. But the problem is he continued. That's where the problem is. And here he shows that he doesn't understand at all what the word exist means, because they put so many things, they have so many notions of what the word exist means that it destroys all notions of a crisp definition. What he's done essentially is cover all the bases. He says exists is also that which is observed, measured, and has effects, right? He's talking about experiments. He confirms that in the next sentence. He says, empirical and material encompassing entities, phenomena, processes detected. He wants to detect something. So he's talking about see-touch. He's talking about empirical, running an experiment, processes. We can't say that a concept, especially a dynamic concept such as phenomena, processes, etc., detection, none of those qualify as exist. But see, he puts it all in there and he says, exist means all of this. Yeah, and that's where the problem is. You can't absolutely put everything in there, okay? And that's essentially what Ayn Rand did. Ayn Rand is some people know her, I call her Ayn. Ayn Rand never figured out. Some people get upset at me, Ayn Randis, because I say that she had no idea what what was the word she used? Entity. She used the word entity, not the word object, but it's the same thing. Entity, object, thing, it's the same word in physics. And anyone using the words entity, object, right, or exist has stepped the line into physics, whether they know it or not. They're no longer talking about philosophy. They're no longer talking about ontology, whatever nonsense that is. They're talking about physics, okay? They cross the line into physics. And so if you talk about the existence of God, you're not talking about religion, you're talking about physics. Not because of God, but because of the word exist. Exist and object belong exclusively to physics. Anyone touching those two words has ventured into physics, whether they know it or not. And so these people say, well, I defined it for philosophy. No such monster. You have to define it for physics, okay? Physics has total monopoly over the word object, total monopoly over the word exist. It's the province of physics, okay? Only physics deals with objects, and only physics deals with existence. Physicists are the ones who are supposed to say what exists out there, okay? And they have to theorize based on those assumptions, especially the invisible entities that are out there. Anyways, you can see here it says, this I looked up, you can see the definitions later on, but it says reality, what is it? Real. That's great. I love the fact that they define reality as real. And then says that what is reality? Something that exists. What is something? Something is anything. In other words, anything. It could be motion, it could be an orbit, it could be an orbital, whatever. You can put anything in there. And that's not true in physics. In physics, the only nouns accepted are the objects. If it's not an object, it's not a noun for the purposes of physics. You cannot talk about the orbit of Jupiter. The way it works is Jupiter is the noun, and orbit is what Jupiter does. Orbit is a verb, okay? So there's no such thing as the orbit. You can't put an article in front of the word orbit, and so on for any concept, okay? And there he says something that exists, right? It says real. What is real? Well, real is occurring, if you look it up. And they use the word actual also to define it. What is actual? Existing and real. So you can see that all these are circular arguments, all are circular definitions, because they rely on synonyms. Okay, you cannot define a word using a synonym or an antonym, by the way. Antonym is the same thing as a synonym in this sense, just the opposite. It's a negative synonym, but it's the same thing. You can't use synonyms or antonyms to define. Okay, here's another fellow gives it his best shot. He's an etherist. He's going to define the word exist. Okay, let's see how he does. He says, exist means to what? Stand up. Okay, I got to stand up to exist. As long as I'm sitting down, I don't exist. Present, right? Out of. Okay, because he's looking at the word present. He says you got to present something, right? That's what he's saying. So what is standing out of? Yeah, I have no idea what you're talking about. And again, I guess he's got an ant brain. That's why I put the little ant there. And that's why he can't make it beyond these things. He just goes around in circles and never reaches any conclusion. He just asks questions that even are unrelated to the word we're trying to define. So what is an object standing up out of? Physical presence. Presence means to present. No. It means location. Okay, that's what we don't care what it means. That's what we meant. Location. Object has location. And what is presenting as physical? So again, he goes around in circles asking stupid questions that have nothing to do with the word we're trying to define, which is exist. Exist, physical presence, object that has location. What part of object, what part of location did you not understand, Location, set of all distances. There's got to be a distance between my chest and God if I say that God exists, okay? And God cannot hide anywhere where he wants. I mean, he can hide anywhere, but wherever he hides, there's going to be a straight line of direction between God and me. Okay, so God cannot escape my line of direction, no matter what dimension he wants to hide in. Okay, and then you can see that he's got really some mental problems. It says, you are of God, power, ether, and there is a force vector out of God power and goes on ranting about who knows what nonsense. I wonder what these people drink. I'd like to have some of that so that I can escape the real world in which I live and all the crazy people that are around me, all these nuts here. So yeah, I have no idea what these people have going through their brains. It kind of makes you wonder on the one hand. On the other, it makes you feel very lonely because you realize there are not that many intelligent people out there, despite what humans are supposed to be. Here, Mother Nature gave us this thing we call intelligence, and all these people squander it. Okay, so here's the definition, of exists, physical presence. That's what it is. What does that mean? That's a shorthand for object plus location. An object that has location. Okay, there you have good old God as painted by good old Michelangelo. And you can see he's got a straight line of direction with a tree, a rock, a table, whatever. So if there's a straight line of direction, and you take the set of all those distances, those separations, right, to each object in the universe, that's your location in the universe. Okay, that's what we mean by location in physics. In physics, not in math. Math, it's distance traveled, how much you unroll the measuring tape. That's what it means in math. In science, means something else. Science, physics, that's something else. And it's just separation, qualitative separation. And you take the aggregate of all those distances, those separations, that's your location in the universe with respect to whatever you're referencing it. Maybe every atom, whatever you're using as a reference. Maybe the moon, no problem. But you have to tell us what the context is there. Okay, what do? Well, they put God usually outside the universe. And here's one fellow, he says, what did I put here? Give me a second here. There we go. I don't know what happened to that one. Anyways, this fellow says, God is out of the scope of dimension. Okay? Time and location. He puts it outside your reach. That's what they do. They say, God is not here, or God is not a thing that you can point to, or that has, distance with respect to yourself, or belongs to our dimensions or whatever. No, the issue is when they say that, they're just trying to put it out of your reach. And of course, they put it out of their own reach. And they say, that's why God is so awesome, because he's out of my reach. And then you have Michelangelo. He was one of the turtles. He painted God. So obviously God is a physical object. You can see it there. It's got shape, right? There you see him a little bigger on the right. So that's God there. So God, you can say he exists. If he's a he, like we see there, right? A human-like figure. We were made in his image, right? So he's got to be an image, a shape of some kind. And there we have it. And there's distance between the universe as the relativists see it and him. So obviously God exists if you put him in that context there. Okay. Now, if God is a concept, well, that's a different story. See, what was the definition? You need an object that has location. And concepts don't have location, such as singularity, black holes, dark matter. None of those have location because they're concepts. They're not objects. They're mathematical concepts. And that's why you can't say they exist. And here's one person who started a lot of that stuff, putting God out of your reach, especially time-wise. And that was good old St. Augustine. And he says, divine eternity is a never-ending present. And then, in a sense, he is right. The present is eternity, okay? Because the Father Universe only exists, right, in the present mode. Every atom from every other atom in the universe. That's Father Universe. So Father Universe is always in the present. Father Universe does not acknowledge time. Okay, and a lot of people don't always understand that. But St. Augustine was in that sense on the right track. But he says, therefore exists separate from time. But he put them outside time. In a way, he's right. God is outside time. In other words, Father Universe is outside time because Father Universe only exists in the present. Existence is something that only is not a dynamic concept. You don't begin to exist or cease to exist. People talk like that, but that's ordinary speech. That's not physics. In physics, exist is a static concept. And that means every atom in the universe at a distance from all others. That's a cross-section of time, cross-section of motion, only location. Okay, that's Father Universe. And again, when people talk about time, like relativists do, well, they're saying you can go to the past and see, Napoleon, go to the future and see your grandkids. That means that instead of every particle moving to a new location, every particle stays where it is, and a new copy of every atom in the universe is created in the next frame of the film, a new one in the next frame, a new one in the next frame, and so on down the line. That's the only way you can go back to frame 541, in the past, and land on whatever existed in those days. Okay, and the same for the future. So the only way you can conceptualize time in that sense, time travel, right, is if every atom is cloned in every frame. So, we have all these slices, as Brian Greene once showed, of the universe. And that means every atom is simply duplicated with every second that passes. Idiocy, complete idiocy. Okay, one fellow asks, he says, I've been trying to think of a good definition of form. And he goes on asking about that. And what we do with the word form or shape, we use the word shape, okay? Usually because shape refers to 2D and form refers to 3D in general terms. In physics, they're exactly the same. They're synonyms, okay? Why? Because shape, we all see 2D. Every object in the universe at least has 2D. And not all objects have 3D. Not all, you take a square, it has shape, but it's not a 3D object conceptually. It's a 2D object. And we include those as well. These are images, these are patterns, these are shapes. And so we just talk about shape. That which has shape is an object, okay? So a square is an object. It's a thing, okay? It's a thing that does not exist, okay? Because in order to exist, it has to have location. And squares don't have location. Okay, so there's the difference. Now, he asks, what's the definition of shape or form? Well, the way we do it, first of all, it's not a key word in physics. Okay, and you say, well, hold it, you define it as an object as that which has shape. Yeah, and we don't need to define the word shape because the issue here is something else. The context. You need to understand the context. And here's the context. Listen carefully. A lot of people don't listen. They ask stupid questions over and over again. The reason, the context is the following, and this is the reason we don't define shape. Right now, the default, what everybody uses out there is see and touch, or the particles that make up an object. Mereology, that's what it's called, okay? So a table is not a table. A table is 500 gazillion atoms that comprise the table. And that's not what a table is for the purposes of physics. Table is that thing I'm pointing to, okay? And we don't know how many atoms it has. In fact, we treat it as an object made of a single piece, like if it weren't made out of atoms or out of anything for that matter, okay? So we don't say, oh, a table is 500 million gazillion atoms. That's not how we say it in physics. The way we say it is, that's a table. You point and name. And that's something we learn in kindergarten. You go to the kindergarten, you have a cube, and you have a ball or a sphere, right? And you go to the kids, 5-year-old kids, right? And you say, hey, kids, and they have the same volume, same weight, same everything, same color, right? And we say, what's the difference between these two objects? And they'll say, it's a shape. That's what they'll tell you, okay? And now you learn the word shape, the word form. We don't define it, we point to it. We compare it for the kids, and they tell you you get the notion of what shape is, what form is. So we don't have to define the word form or shape. Only devil's advocates, extreme devil's advocates say, oh, Bill, what did you mean by shape? And the way we answer is, why didn't you ask, the definition is that which has shape. Why didn't you ask for the word that? Why didn't you ask for the word which? Are those easier to define than shape? In fact, they're not. They're much harder to define, believe me. So we don't define that and which and or and but. We don't define any of those words. We don't need to define them. We can use for that, for the dissertation, we can use the notions of ordinary speech for those words. Okay, we don't have to define them all over again. We don't go through the whole dictionary. We only define the key words that we need to define. The word we need to define is the word object. Why? Because mathematical physics uses informally, right? the definition of ordinary speech, or the notion that people have out there, which is see and touch. And no, an object is not that which you can see or touch. Okay? Especially in the case of black holes and dark matter, you can't see or touch them. Okay? So they have no property of see and touch. And what it's made out of? Well, black hole fails there as well, because what is a black hole made out of? Nothing. Absolutely nothing. Okay? They say it's made out of mass. But you can't have mass without matter, and black hole crushes all matter out of existence, so we have no mass either. Okay, so here's another fellow who says, ether is not a particle or a sea. Everything is swimming in. Because, the way I look at it, and the way everybody's looked at it since the days of the Greeks at least, and even before then, is that ether is simply a bunch of particles that form a background to what they say is real matter, or visible matter, or touchable matter, or whatever. Okay? And so these people don't like, they want to turn ether into a concept, but then use it as an object. That's where the problem is. They define it as a dynamic entity vibrating in the background there, right? And then they want to use it as a battering ram. They say, oh, the ether was dragged, or it was moved, or it moved something else, or it vibrates. So, on the one hand, they define it as a concept, then they start vibrating this concept. That's where the problem is, okay? You don't vibrate concepts in physics. Okay? And so, see, ether says cannot be dragged around. And the next statement, he says, ether disturbers. So here you have magnets, they disturb the ether, but ether cannot be touched or dragged around. Why? Because it's a Cartesian whatever nonsense, pure potential ether. He defined it here somewhere. Well, let me keep going there, see if we can find it. Says, you will, if you have two magnets, right, and you put north to south, right, you will see and feel the non-force of acceleration. The non-force, okay, of acceleration. As the two magnets come together, inertially inward, centripetal, convergent towards what? Rest, pure potential ether. Whatever nonsense all that meant. Okay? Yeah, they treat it as a concept, but you want to use it as an object. That's where the problem is with ether. And no, ether is a bunch of particles. That's all it's always been. Nothing has changed in the last 3,000 years. These people want to give it some kind of notion beyond your reach again. They never define it, like God and like all these other key words, space-time. They don't want to define it, right? They want to put it out of your reach. Where's the end of space-time? Well, it's infinite. What's a singularity? It's infinite. Everything's infinite. Out of your reach, where the laws of mathematics break down. So they put it out of your reach. That's all there is. They don't want you criticizing their religion, their icons, their angels, whatever they believe in. And so, because they don't want you to criticize it, they say, look, we put it out of your reach so that you can't touch my God. That's all they're saying. Okay, here's another fellow. He says distance. He says, he defines length as the distance between the start of an object to the end of an object. No, it's not the distance. Distance is separation. It's where there is no object, empty space between two objects. That's the distance, okay? Separation. And so I like to say distance is what lies between lengths. Length is what an object has. Distance is what an object doesn't have. Okay? What's between two objects. That's called distance. And these people will never understand that. They're talking about distance traveled, which is what mathematics uses, Mathemagix, or as I'll call it today, MASSeMASSics. And so what is it, what they're doing is really putting it out of your reach, all these things, all these words. They're defining it in very abstract terms, and then they have contradictions, because if distance is separation, that's different than unrolling your measuring tape, the tip of your measuring tape, and talking about distance traveled, which gives you a number, once you establish a unit, and they're going to say it's 10 centimeters. No, 10 centimeters not distance. 10 centimeters is distance traveled. Okay, it's a dynamic concept. You unroll your measuring tape to get those 10 centimeters between two objects, right? Two surfaces or whatever. Now, in physics, separation, qualitative. We don't have numbers. We don't use numbers in physics. We don't need numbers to explain physical interpretation, to give physical interpretations. Okay. And final question here, person says, have you developed the basic mathematic formula formulae involved in describing your rope model as it relates to various aspects. It would serve as an enticing way of luring more traditionally minded scientists to at least give your overall theory the more serious attention it deserves. Well, essentially the only equation I use is C equals frequency times wavelength, C being the velocity of light, 300,000 kilometers per second, right? And why? Because that's the equation of a rope. There's only a rope can can simulate that equation. There's no other object can do that. And so we have established that the velocity of light is somewhere around 300,000 kilometers per second, and we have established when the frequency goes up, the wavelength goes down, and vice versa. They're inversely proportional. The only way you can explain it is with a rope, okay? Why? Because frequency is the number of links. That's what we've been talking about all these centuries. And wavelength is the link length, okay? And so now you have fewer links, and each one is longer. Now you have more links, and each one is shorter. That's that equation there. That's what it was all about all these hundreds of years. The wave equation is the equation of a rope. Now, you can also look up the equation for torsion. There you see it on the bottom. For those who are interested in doing some math, yeah, sure, the equations are already there. I don't have to develop anything new because the equations have been there all along. The problem is that nobody talks about torsion. Everybody only considers there's only two types of waves, and that's longitudinal and transverse. And when you talk about torsion waves, three-dimensional waves, they kind of say, oh, what are you talking about? And so very few people on the planet, mathematicians, deal with these equations talking about torsion, okay? And, I'm sure that 99% of mathematical physicists have never even looked at torsion. They don't care about torsion because it's something that they don't deal with. They deal with transverse waves, which are two-dimensional, up and down, standing waves kind of thing. And so, they're not in tune with torsion. They never realize that torsion is the fastest thing known to man. This thing, torquing, right? This is the fastest thing known to man. And, you can prove it to yourself the way I did it. You can run a little experiment at your home, tie a rope, your grandmother's rope, close line, and put two pins at the end. And you can film it, which is what I did, and you move one pin, the other one moves instantaneously. That's how fast torsion is. No transverse wave, no longitudinal wave is as swift, as fast as a torsion, and it shows you why light is a torsion, why it's so fast, right? And only a torsion wave can travel at 300,000 kilometers per second, okay? And yeah, no human, no object will ever be able to travel faster than the rope that's in between. And all they can do is slide along the rope and torque it at the same time. But you cannot travel as fast as the torque. There's no way. So yeah, I don't need to use Einstein's equation of E equals mc squared or anything like that and say, oh, mass turns into energy. I don't need all that nonsense. I can just tell you physically, qualitatively, why you cannot travel faster than a torsion. Torsion is already there at the other end. So you torque here, it's already torquing at the other end because it twirls in place, in situ. Whereas, the transverse and longitudinal wave, they walk like turtles in comparison. You have to go from A to B, you have to go one way. Torsion, two-way signal. Okay, so let's move on to the main course of the day, okay? And that's going to be mass. What is mass? My God. And that's continuing with what I started the other day. We've been looking at mass and gravity and black holes and so on. So let's look at this. Here we have some of the questions, some of the comments people made since I put these shorts out, started with the shorts. And here's this fellow says, describing black hole as infinitely dense and infinitely small is an incorrect concept to explain black holes. Okay. And he says, I have come up with a better way of understanding dynamics of black holes. Okay, let's see. Black holes, I believe, are objects that are so heavy that they crush themselves into a smaller and smaller object, unable to reach its smallest point because there is no smallest point that matter can reach. according to what? The laws of the dimensions. Laws of the dimensions. What is he talking about? But this is what he's talking about as far as, becoming smaller and smaller and never reaching a smaller size, right? And there it is. That's illustrated there for you. What they're saying is you're falling to a point, right? But you never reach the point. You're traveling forever. It's infinite, as they call it. That's the word the mathematicians like to use, infinite or infinitesimal, right? You're approaching the so-called singularity, but you never make it there. You're always falling. Why? Because what do you say? The laws of mathematics are what? Crushed out of existence at a singularity. The equations are crushed out of existence there. So, you can't get there because it's very dangerous. You'll be crushed out of existence. But fortunately, you never make it there. So I guess you survived the trip because you travel forever. So this is quite a bit of nonsense. But this is what they're talking about. They're saying, look, it becomes smaller, smaller, and smaller. You approach the singularity, but you never make it there. And the laws of physics break down, and all this nonsense terms that they've created, all these people just parrot. They just memorize and say, oh, but the laws of physics break down. Whatever nonsense that means. It means infinity. That's what it means. Infinity means that you travel forever, And in the case of black holes, that's a serious problem. It's a fatal problem because it means that all the matter is still inside the black hole. So they have a contradiction. On the one hand, they say all matter is crushed out of existence. That's what half of the mathematicians say. The other half say, well, no, you don't really get crushed out of existence because you never make it to the singularity train station. The train station's there and you're always approaching it, but you never make it. It's like the Achilles and the turtle thing, where he only travels half the distance and half the distance, half the distance, half the distance. And he's always half a distance away from the train station, the singularity train station. And that's where the problem is. This is irrationality of mathematics. It has nothing to do with physics. Physics, we don't have something called singularity, or that you approach a location and never make it there. No such, unless you die. Maybe it makes it at least, dead. But, there's no such thing as not being able to approach a location. And what these people say is singularity is a location, a place, a position, or whatever you want to call it, a little space, a region, and you're always approaching it but never make it there. And that's idiocy. That's mathematical idiocy from Cambridge and Harvard. That's what it is. Okay, so what are these laws of dementia? Let's see. This guy says laws of dementia. And I looked at some of the things he wrote. Transfer of information. He transfers information. And information the wave carries. A wave carries information. And he says something about dimensions being related to temperature. What does temperature have to do with dimensions? I mean, this is a dimension. That's what it is. Total dimension, what he's got there. And talks about energy, potential energy within, mass, fabric of space. What is that? What's space? Space is nothing. There is no fabric. But these people talk about the fabric of space-time, of time, of absolute nonsense that they've fed these people in their heads, and they just, tiny brains couldn't not absorb all that information, blew their brains out. So they talk about fabric of space and energy and what? Space stretching. They're going to stretch nothing. Okay, good. Good luck with that. You'll spend the whole day just stretching nothing, Okay, that must be a lot of fun. Okay, so here we have another one that says, black holes have been proven multiple times to exist. Of course, he doesn't know what the word exist means, so he just uses it. He says it exists, whatever that means to him. Just look it up, okay? Where are his examples? My examples. Where's his proof? He looks for proof, evidence. He wants me to convince him, persuade him, recruit him. No, we don't do that in science. We explain the mechanism whether you believe it or not. We don't twist any arms. Okay? Blurking out faster with no context or explanation. He says black holes have no mass because of what? They are zero-dimensional. Exactly. If it's zero-dimensional, there's nothing there. Zero-dimensional is the definition of empty space, of nothing, of vacuum. That's what zero-dimensional is. Zero volume and zero matter, because they say black hole crushes all matter out of existence. There's nothing there really between the singularity and the event horizon. So what do we have? We have absolutely nothing. So they say, well, but it has mass. What do you mean it has mass? Mass is the quantity of matter, right? And there is no matter. It's been crushed out of existence. So you don't have any mass either. So, but even if we concede all that, let's concede that it's got mass, it's got tons of mass, gazillions, infinite mass. I don't care. You put as much mass as you want. Okay? Listen carefully now. Okay? You got all the mass that you want. Okay? Just put a number there, whatever satisfies your strange feelings. Okay? So you have all this mass. How does that mass physically compel a star to move around the black hole? That's what you got to answer. If you can't answer that question, you got garbage in your head. Okay? Don't tell me that mass moves a star around. No, mass cannot do that because mass is a mathematical concept. You have to tell me the physical mechanism. How does that famous mass, whatever that is, right, move a star around? Okay? What these people are saying is that there's an influence there. Yeah, you got to tell me what the physical entity is, what the mediator is. If you don't have a mediator, you cannot explain rationally how a black hole moves a star around itself. Okay? What you're saying is mathematically, look, mass moves so far away, another mass. Mass times mass divided by distance squared, blah, 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 right? No, that's in math. In physics, you got to show us a physical mechanism. You got to show us some mediator, something that we can see or touch, right? That's what people say that a physical entity is. So show us what we can feel, what we can see or touch, what we can feel, what we can run an experiment with or whatever. Okay, what do we have between the black hole singularity or the black hole event horizon or black hole whatever and the star? What's between that? That's what we want to see. Okay, put something there. You can't put anything there, you got nothing so far. You can't say, oh, mass moves a star around. That's idiocy. It's called idiocy in physics, okay? Okay. So here we have another fellow. He gives it his best shot. He's saying black holes don't have mass is ridiculous. Oh. Okay. They exhibit extreme gravity, so we don't know definitely that they have mass. Okay. And so what is this mass that they have? Show us a picture of this mass that they have. What is it that they have, right? It says, he seems to be arguing that black holes have no mass because they are zero-dimensional. Yeah, and then he says none of these claims are true. That it's not zero-dimensional and, all mass has been crushed out of existence, right? So all matter has been crushed out of existence, so it has no mass. It has no dimension, so obviously we are talking about nothing. Okay, so far we have nothing in front of us. And he says, however, the nature of a singularity is not well understood due to the breakdown of current physical theories at that point. Okay, so he's saying, he's just repeating stuff that he heard out there that the mathematicians, people like Brian Greene and Neil Tyson, all these people feed garbage to the public, and these people just swallow it. They never criticize it. They never question it. They say, oh, what a genius Tyson is. What a genius Brian Cox and Bill Nye are. They're such geniuses because they do all this math. They went 10 years to college and they learn how to do all these equations that these people don't understand. And so they say, oh yeah, it's got so much mass. They never question, what is this mass? What is it? This mass that moves stars around, that compels them to orbit around the black hole, this center called the black hole, this singularity. And by what mechanism? And they never ask these questions. They never even crossed their minds to ask these questions. That's what you got to put them on the spot. In fact, I will be putting them on the spot today. You'll see towards the end. Okay, so here we go. Where did I get all this? He says, where did I get it? I just came up with this out of the top of my head. No, here it is. Okay, listen carefully. This is one of your gurus, Hawking. Stephen Hawking. You know who Stephen Hawking is? Guy who died a few years ago, and he talked a lot of nonsense, more nonsense than anybody else. But this is one of the things that he said. Okay, this is in his book, so you can look it up. I didn't invent this. Here it is. He says, Eddington was shocked by the implication, that a black hole would collapse to infinite density. In other words, a star would collapse to infinite density, meaning a black hole, right? And he refused to believe Chandrasekhar's result. Eddington thought it was simply not possible that a star could collapse, what? to a point. Point, dot, no volume. That's what they mean by point. Einstein himself wrote a paper in which he claimed that stars would not shrink to zero size. Do you know what zero size means? Zero size means nothing. Zero size is zero dimension, zero shape, no volume, okay? Zero radius, zero diameter, zero whatever, all the zeros. Whatever other zero you can think of, that's what is a black hole. So it's 0, 0, 0 all the way, and if it's got zero matter, because all matter is crushed out of existence, it's got zero mass. So yeah, I didn't invent all this nonsense. It was invented by idiots like Stephen Hawking and Einstein. Well, Einstein was against black holes, but a lot of people don't know that. But Chandrasekhar, Arthur Eddington, all these people is the ones who gave us all this nonsense, okay, about black holes and so on. You have other people who came later on, like Hawking himself, Penrose, and so on. And in fact, Penrose won the Nobel Prize a couple years ago because of black holes. And all these people created this black hole nonsense, and all these people just believe it. They say, the black hole. Yeah, what is a black hole? Please draw it for me. And he goes, they took a picture of it. What did they take a picture of? If it's zero dimension, they're telling you, zero size. How can you take a picture of zero size? Please come down to earth, bean brain. Okay, so yeah, they have all these notions that these mathematicians fed to them, and they never questioned it. They said, Stephen Hawking, he must know. So what Stephen Hawking did was put his brain in the heads of these tiny little brains that these people have, Okay, so here goes. Well, it says, if black holes don't have mass, then explain how they have gravity. Okay, I'll get there in a second. They have mass, they have gravity. Let's see what else they have. Okay, he put a comment, this fellow put a comment a short while ago. I got it at the last moment, so I put it up here. It says, can you tell me how black holes are formed? Making statements that are literally the opposite of what? The scientific consensus. Scientific consensus, scientific they call it. Yeah, black holes are scientific, sure. Your insistence that black holes are literal singularities and therefore can't exist is an indication that you're the one taking abstractions too literally. So he recognizes it's an abstraction, and he says that I'm taking this abstraction and I'm the guy who's at fault because I'm turning the abstraction into something solid, into an object, into a thing that we deal with in physics. Physics only deals with things. Okay, only with things. You have to have a thing to have physics. No things in the universe, nothing, no physics. There's nothing happening, nothing going on, nothing to measure, nothing to test, nothing to experiment on. You're not watching anything, but there's nothing there. You have to have things in physics. Physics starts with objects. You have to have an object. And these people talk about abstractions. You say, I'm making the abstraction into a physical object. These people are saying a black hole moves a star around. It had better be more than an abstraction. You had better make it literal. Okay? It had better be literal that a black hole has something there. And he says it does. It has mass. Yeah. What's mass? Mass is what? A physical object. I can hold mass in my hand and say this is what is inside a black hole. All this masses, all these masses, all this mass. No, you have to have a physical object. Black hole is not a physical object. In fact, it's not a physical object under the scientific definition of object, which is that which has shape. It has no shape. Zero volume, no shape. Zero dimensions, no shape. Okay, and it's not an object even by the definition that mathematicians use, which is see and touch. You can't see it, and you can't touch it. So far, a black hole is not an object, not a thing. And he's saying I'm turning that concept, which they call mass, into a physical object. No, you're doing it. You had better do it because it has to be literal. Physics is literal. You can't use abstractions like, black hole singularity and say a singularity moves a star around. That's where the problem is. It's a semantic problem. It's a problem with them trying to give a physical interpretation to their mathematical equations. And of course, they're going to bomb out. They can't do that. They can't give a physical interpretation with this nonsense. Okay, so here are all his irrational statements. I made a list here, a small list. In physics, it's irrational to say that you have a headache. Okay? You can't say in physics that you have a headache. Okay? In physics, you can say that you have a dime or a dollar in your pocket, but you cannot say that you have money in your pocket. Okay? In physics, you can say that you cast a gold coin into a well. It is irrational to say that you cast a Bitcoin into a well. Okay? I hope you're following along here and understand what's going on. It is irrational in physics to state that you sent or received information, or to say that information travels or was destroyed. You know, these idiots from math, they say that information was destroyed inside a black hole. Information was destroyed, yeah. It is irrational in physics to say that a black hole has gravity. Gravity is a concept. You cannot have gravity. In physics, it has to be an object to go with the word have. The verb have cannot be used with concepts. Okay? And so all these people are talking idiocy because they learned the idiotic language from mathematicians. And so they say, oh, I have a headache. No, you do not have a headache, not in physics. In physics, you cannot have a headache. Okay? You can have a head, but not a headache. And likewise, in physics, it is irrational to say that a black hole has mass. What is mass? I mean, is there a physical object that called mass? What are you going to show me? What is mass? Mass is a concept. You cannot say I have a concept. Not in physics. In ordinary speech, you can say you can have love, you can have intelligence, you can say whatever you want in ordinary speech. In physics, you can only have objects. And black hole is not an object, not a thing. And if it's not a thing, it cannot have effects over other things. Like, move stars around itself, a black hole, Okay, so here, let's continue. We have this. There was a program in the 60s that I watched, Cowboy, and it went like this. The name of it was Have Gun, Will Travel. Those of you of my age know what I'm talking about, probably, because it was a quite popular program. Have Gun, Will Travel, and you can see what these guys have in their hand. Those are called guns. Now, a mathematician would not understand it, so I had to write to the people in Hollywood and ask them to change the title because all these mathematicians were not understanding even the title of the program. And so this is what they changed it to. This is the new name that they have today. It says, have mass will travel. That they understand. But if you say gun, a mathematician will not understand because gun is a physical object, and they don't understand what physical objects are. So if you say have mass will travel, they understand that. They say, okay, I see. So in physics, or in mathematical physics, in the religion of MASSeMASSics, right, you have to have concepts. You cannot have objects, okay? You can have a concept and then you can travel. Otherwise, if you have an object, they don't understand what you're talking about, okay? You have to have concepts. And this is where the problem is. It's a severe semantic problem. The mathematicians haven't defined any of their concepts. You ask them, what's mass? We don't know. What's time? Well, we don't know. We're still searching. We're still doing research and development. You ask them, what's a black hole? We don't know. Singularity, we don't know what's there. The laws break down in there. And so on. They don't know what energy is. They don't know what field is. Field is a bunch of numbers, and then they use it as a physical object, and so on. So they have all this language that they created, irrational language, which they teach everybody in high school and later on in college. And people just swallow it. They're just talking, the energy, the field, the wave, the ether, and so on, the space-time. They take it for granted. All these words are known, that we know what they are. And this is where the problem is, that none of these words belong in physics. None of them. In physics, you have table, you have chair, you have rock, you have tree, you have dog. Those are words that belong to physics. Words like field, energy, mass, force, time, none of those belong in physics. They have nothing at all to do with physics, because in physics we have to give a physical interpretation. Okay, so here it is. We have 7 definitions of mass today. This is according to the Wikipedia. They put 6 out there. And the first problem there, as I talked about the other day, they're operationally defined. And that's a no-no. That's an irrational definition if it's operationally. Operationally or functionally functional definition. those are irrational definitions. The person talks all day long, his dissertation, he gives a presentation, and at the end of the presentation he says, let me tell you what I was talking about all this time. And that's when he says it was defined by all the stuff that I said. So that's the definition of whatever he talked about, you know. And so that's the problem with mass. It's defined operationally or functionally, and that's irrational. And they have all these different definitions. One where it's resistance, you know, inertia. Another one where it's weight, a synonym of weight. Many mathematicians want to deny that, but it's true. There they have it. Gravitational mass, you know, measure the strength of an object's gravitational flux, and that's weight. And then you have rest energy, which is quantity of matter. And they call it rest energy or rest mass or whatever, you know. And what they're talking about is, you know, the object there, what are we talking about? It's not moving. So what we're talking about is the quantity of matter, how many atoms it's made out of. Okay, so yeah, they have all these different notions, and that's why they can't tell you what mass is. And, you know, they have all these definitions. They say a black hole has mass. Well, which one of them? Does it have gravitational mass? Is it inertial mass? Is it, you know, what is it? Static mass, another rest mass? What kind of mass does it have? You know, we have all these color masses, the red, the blue, white, and blue mass. And we need to know if it's red or white or blue, you know. You got to tell us. What mass does it have? And so here's the two primary ones, okay? We have the quantity of matter, which is the rest mass, and it involves counting, okay? We need to know how many atoms form an object when it's standing still, when nothing's moving, when you're not comparing it to anything. We just need to know how many atoms are in that stone or whatever you have in front of you. And in this case, we have 1 trillion atoms. And that's the way you would have to specify the mass according to the definition of quantity of matter. If it's quantity of matter, you have to specify it in number of atoms or number of units of mass, whatever unit you choose, you know, and you say, well, this one has 1 trillion atoms. Okay, we all understand that. Okay, it means that if you were to count all the atoms that make up this object, you would end up with 1 trillion atoms, right? And on the other hand, you have this other one, which is gravitational attraction or inertia or all these other dynamic masses invented by the mathematicians, right? And this one you weigh. You have to push it against something, right? Or you have to speed it up. You have to run it at the speed of light or close to the speed of light. And here, this one weighs 1 gram. So the question is, which of these two notions are we going to use? Are we going to use the quantity of matter or the weight? What I call weight, which is the 1 gram, you weigh it, right? You take it to the moon, you weigh it, you take it back to Earth, you weigh it. That's how you determine the mass. And they say, well, no, the mass didn't change, what changed was the weight. Yeah, but so did the mass, because the way you determine mass is by weighing. So, yeah, mass and weight are exactly the same until you can figure out how to separate them. You know, and right now, they don't even understand the difference between counting and measuring. Because if mass is the quantity of matter, you should express the result in terms of atoms or units of mass, whatever unit you decide to use. Okay, so that's where the problem starts. And because of this, you have all these great men of science like Neil Tyson who cannot explain anything. And they cannot explain for sure gravity. They haven't been able to in thousands of years. And here you have the simplest thing in the world, gravity. I mean, you know, here it is, gravity, okay? Watch it very closely. You let go of the pen in this case, right? And it falls to the ground. That's the only experiment you ever needed. Now we need to explain it. Why does this pen fall downwards? That's what you need to explain, okay? And they cannot explain that. They say, look, I can tell you how fast it travels and how warped the space is here and all this nonsense, but they cannot tell you what caused it to come down. Something so simple. I mean, this is as simple as it is, okay? Very simple, baby stuff, kindergarten stuff. And here, let me bring Neil to tell you all about it himself, okay? So give me a second here. Here it goes. Listen to him carefully, okay? This is Neil Tyson, okay? Here it goes.
Science can describe how gravity works, but can they describe why it works? So this is the how-why duality here. In science, if we can describe how something works and predict its future behavior, we claim to understand it and we move on. Gravity is the curvature of space and time, and you're moving on the curvature of that fabric. That's gravity. I can describe what gravity is doing, I even have a mechanism for it. You say, why did it fall? I say there's a force of gravity operating on it. Why did it fall that way? Because of the curvature of space and time. I'm answering your whys. Then, well, why does matter and energy curve space and time? Okay, that's a frontier. We're still working on that.
Okay, so what does Neil say? He's working on it. He's still working on it. And they're going to work forever because they're trying to give you a physical interpretation, but they can only give you a mathematical interpretation, and they can't turn that into words. They can't turn their quantities into quality. Quantitative into qualitative, right? They can't give you a qualitative physical interpretation of how gravity works. And they never will. They never will because it's not in their line of work. They don't do, I mean, they want to understand gravity, but they'll never understand it because they think they're going to approach it through math, through some kind of equation, you know, and they say, let me develop the equation that tells it what gravity is. And they never will. I mean, already Newton gave us the equation, mass divided by distance squared. Okay, there's the equation. That's all you needed. You know, here you have, again, the pen, and it's pulled by everything on Earth, okay? And so the question is, you know, you have this mass, and you have the mass of the Earth, and you have a certain distance. The closer it gets, the faster it goes, right? We've all experienced that, you know, at home and everywhere. And so we already have the equation. We already have everything we need to know. We just need to explain it now. And these people cannot explain it. Why? Because they never identified the invisible, intangible objects that are in contact with a pen. And so they say, well, there's nothing there, Bill. Yeah, because they think that an object is that which you can see or touch. And they say, I can't see or touch, so there's nothing there. No, there is something there. There had better be something there. Otherwise, you're doing witchcraft. You're doing black magic. You're doing voodoo physics. Okay? That's, if you don't put anything there, you're doing voodoo physics. Okay? And so this is why Neil has no clue whatsoever. He never will, because he's not a scientist. He's not a physicist. What he is a clown. And I'm not offending him. Okay? He is a clown. He's in the entertainment business. But people think that he's a scientist, that he's a physicist. No, he's a clown. He's a buffoon. He's trying to make you laugh. He's trying to entertain you. That's what he does. Okay, so people get the wrong ideas about Brian Greene, Neil Tyson, Brian Cox, and all these people who are out there. They're out there to entertain you, not to educate you. And people come to their program and say, oh, I got my shot of science for the week. No, what you get is a little entertainment, that's all. Distraction. And so this is the reason deGrasse cannot tell you anything. He says there's a difference between how and why, and he never understood that. He doesn't understand the difference between description and explanation, okay? And how is a description, why is an explanation? A cause, the mechanism, okay? Neil states that mathematicians who call themselves physicists are satisfied with descriptions. He says that, and then he tries to explain. He says they're satisfied, but they're not satisfied. Okay, I'm going to try to explain. What does he say? He says that gravity is the warpage of space. Well, that either he's very ignorant, extremely ignorant, or he's trying to wing it. He's trying to pass one through you. You cannot say that here in this region space is warped. Not the field equations that Einstein uses. They only work out there. They work out there in the cosmos. They don't work here at our level. That's why quantum mechanics cannot explain, gravity. Because if general relativity could be done here at this level, hey, then we wouldn't need quantum gravity at all. Because we would have an explanation of why this pen falls at this level, or an atom falls, or whatever. It doesn't. Anything here on Earth. We would be able to have an explanation for. You cannot say that space is warped here so profoundly, like in a black hole, that this falls, like it falls at 9.8 meters per second squared. Okay, you cannot say that, and these people don't understand. So he gets away with talking nonsense. Neil should know, if he studied 10 years at the university and got a PhD, he should know that you cannot apply general relativity at this level. And so he's lying, or he's ignorant, one of the two, okay? And he says they can't explain causes, but then he tries to explain. He says we can actually explain why. He says that to you. And what is the cause of gravity? Warp time. What kind of answer is that warp time, that time is warped, that you have this wall of warp time, and that's the reason the Earth doesn't fly out of the solar system, because time is warped. There's a wall of time. And that's when these people say, oh, Bill, you're taking the abstraction too literally. Yeah, tell me about it. I mean, it had better be literal. I mean, you're telling me a mechanism, you're saying the reason the Earth doesn't fly out is it's in this depression in a bunch of number lines, and one of those is time. It forms a wall, it's in this depression, and that's why the Earth doesn't fly away. That's not an abstraction. You're telling me a mechanism, and you're explaining your mechanism, objects, and you're explaining them with an abstract concept called time. That's what you're doing. And these people don't realize that. And so why does mass warp time downwards, Neil? And he said, we're still researching. Yeah, he never will explain why. In fact, he's using gravity to explain gravity. He's saying, the reason something is warped is because you're weighing it down. And that's Newton's force. And I thought Einstein's field equations destroyed Newton's force equation. So we need a force to create the depression. And then he says, then gravity works. Oh, yeah, but you needed a force to create the depression. So, okay, so what is it that we do absolutely need to explain gravity? Here we'll have Richard Muller, another teacher, professor, instructor at University, Berkeley, I think it is. And he's going to tell us what you need to explain regarding gravity. Listen carefully. He's telling you exactly that the following. He's saying that every atom on Earth is bound, is tied, is connected, physically connected to every atom in your body, or every atom on the surface of the Earth. Here it is.
If you have the Earth with its big mass in it, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it. You're pulling on atoms right now on the other side of the Earth. On the other hand, there are a lot of atoms here you're pulling on. You're pulling on all of them. The amazing thing about gravity is it goes right through things.
Okay, we got that? Every atom in your body is pulled by every atom on Earth. Every atom on Earth is being pulled by every atom in your body. How do you pull unless you have an elongated object such as, in this case, a rope? Maybe it's a string, right? I don't care what you use, but you had better have an object. Otherwise, how do you pull? How do you pull on the donkey if you don't have some mediator, a rope or a wire, some elongated object? How do you pull? That's what you got to explain. And are you going to pull with mass? Is that what you're going to pull with? You're going to pull with force or with energy or field? What are you going to pull with? And so you have to identify the object. And there had better be an object here when this thing falls, right? There had better be an object, or here, wherever. I don't care. You can say a lot of particles are pushing, fine, because they're touching the pen. Or you can say something is pulling, which is the case with Richard Muller. He says something is pulling on every atom of the pen. How do you pull without a mediator? Okay? And people don't understand physics. They want to do math. We don't care about math. We want to know the mechanism, the cause, okay, the physical interpretation for why a pen falls to the ground. And he's telling you every atom of the pen is bound, is connected, is being pulled by every atom on Earth. There had better be an elongated object that we cannot see or touch that binds every atom on Earth to every atom of the pen, or of you for that matter. Okay, so this is what I call it now. Here it is. We changed the name. It's called MASSeMANtics, or because there's a lot of semantics there involved, right? Or you can call it MASSeMASSics. MASSeMASSics. And yeah, they say a black hole has mass. Mass pulls on a distant star. All that mass falls into a singularity. But we don't know what happens there because the laws of math are crushed out of existence. It's like asking, what's north of the North Pole? This is what people swallow, this stupid idiocy, these cliches that they've invented. What's north of the North Pole? Well, hopefully there's something like, Polaris or a star out there, maybe Andromeda. To say that what's north of the North Pole. They get you with all these, and people suddenly, and they say, oh, what's north of the North Pole? Oh, that went over my head. I got to think about that. And meanwhile, the guy won the conversation. Yeah, another sucker bites the dust. And he leaves laughing at you because you're saying, oh, you swallowed the expression. Oh, what's north of the North Pole? What could it be? They get all these people, these morons, with these cliches. It's so easy to convince them. And it's all on the basis of authority, Okay, so let's do some magnetism. Some people had questions on magnetism. Let's find out what this is all about. And people ask these questions, says, how do magnets attract each other? Good question. That is a good question. Someone says it's magic. Another fellow says, you have not explained it either. Well, I haven't explained. I explained it many times, the mechanism. Okay, the cause, the physical mechanism, right? And he says, something about experiments, and that they've done a lot of experiments. Yeah, they do experiments. Here's an experiment. Look, that's an experiment. Watch, observe, okay? Watch carefully and make predictions if you want, right? Here's it. Two magnets, right? Those two dark holes there. There it is, okay? It attracts, right? And there's another, I don't have another one here. I guess I'll have to get one next time. But anyways, you have, if I turn it around, it pushes them away. Okay, fine. So we've all experienced that. So that's the only experiment you need. You don't need any other experiment. Now you need to explain what's happening here. Okay? And one thing I'm going to tell you is nothing is pushing my hands. I can feel that it's not pushing. Something's pulling these things out of my hand. It's already, pulling from the inside. So there's a pull force in there. Okay? There's a pull force. There's a tug. There's an attraction. Okay, it's not a push. Okay, and people say, well, we'll do a Casimir effect. You remove all the stuff from here, and whatever's on the outside pushes my two hands together. That's not the case. You don't feel any push from the outside. It's in fact, maybe I can hold it like this. You can see. Yeah, it already attracts it. It already takes it inward. Okay, and again, there's a pull inside there. You got to explain that pull. And these people, some of them say that they already know it, that's been proven and taught to them in high school. Here's one fellow. He says the following. He says how magnets work. That's something we usually learn in school. Oh, I didn't learn it. Maybe you went to a different school, maybe a different monastery, I guess. It's pretty much factual. Okay, no need to think about something that has been proven. They look for proof, right? Daily over 1 million times. Okay? Yeah, and this is the issue. The issue is that these people talk about proof, and they talk about a description. They say, yeah, positive attracts negative. North attracts south. There's your explanation. That's not an explanation. And this is the problem. The problem, these people don't understand what a mechanism is. They don't understand what an explanation is. They take descriptions for explanations. And they walk away and they say, oh, I understand. And you have north attracts south. Hey, that's so easy. And this is the problem. They have no mechanism, but they think they did. And that's why all these mathematicians can bamboozle them, and tell them whatever they want. Okay. Here's another fellow says, there are literally thousands of experiments you can do with magnets, and they know exactly what is in that region. No, they don't. That's the point. In fact, since the days of Faraday says, those lines of force, those are real. There's something in there. And Maxwell also said, there's some exotic matter in motion, as he said, in there. There's matter in there. And people say, well, I don't see anything. I don't see anything between the magnets. I don't see anything in there, so there's nothing there. Yeah, there is something there because something is pulling. And you can see that when you put the magnets underwater, and I've shown that in the past, where you can see, one iron filing is pulled into the magnet one at a time. Gradually you can see, because they do it in slow motion, and you can see all these iron filings slowly approach the magnet. So something is swirling in that region and picking up one iron filing at a time and pulling it towards the magnet. That's what's happening. There is matter in motion around a magnet. You can't see it, you can't touch it. There is something there. Okay, a field is not an object. Field is a region where all this activity is going on. That's what a field is. So you can't use the word field in science. Okay, it's an irrational term because all you're saying, a region. There's a region there. Yeah, there's a region. Regions don't do anything. You have to put something in the region for something to happen. And people don't understand that. Field is let me know if you can see me and hear me. I'll continue as soon as someone lets me know. I think I'm back on. Let me know if you can hear me, see me. Anybody there? Can anybody hear me, see me? Please put a comment. Back. Thank you. Okay, I was talking about Richard Feynman and the fact that he was asked the question, how does a magnet work? He wasn't able to answer it. Let me put this again. He didn't understand the difference between a cause and a reason. Reasons why someone did something, and cause is more objective. It's got to do with things acting according to whatever they do, some motion or whatever. And here it is. Let me put them on again one more time so that you can hear it from the horse's mouth.
Aunt Minnie is in a hospital. Why? Because she went out and she slipped on the ice and broke her hip. But it wouldn't satisfy someone who came from another planet, knew nothing about things. First, you should understand why, when you break your hip, do you go to the hospital? How do you get to the hospital when the hip was broken? Well, because her husband, seeing that she had the hip was broken, called the hospital up and sent somebody to get her. You're perpetually asking why. Why did the husband call up the hospital? Because husband is interested in his wife's welfare. If you try to follow anything up, you go deeper and deeper in various directions. I'm not answering your question, but I'm telling you how difficult a why question is.
Okay, so if Richard Feynman, who had a Nobel, did not understand the difference between a cause and a reason, he's talking about reasons here, why they took his aunt to the hospital, that's got nothing to do with physics. He's using the wrong example. Obviously, he never learned that there's a difference between causes and reasons. But this is the key point here. He had no idea how a magnet works. And again, let's hear it from the horse's mouth. Here it is.
All I can say is that there's a magnetic force that makes them repel. When you turn them the other way, they attract. It has to do with the fact that in iron, all the electrons are spinning in the same direction. They all get lined up, and they magnify the effect of the force. Well, I've just have to tell you, that's going to be one of the things you'll just have to take as an element in the world, the existence of magnetic repulsion or magnetic attraction. I can't explain that attraction in terms of anything else that's familiar to you. So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do. But I really can't do a good job, any job, of explaining magnetic force because I don't understand it.
So, can Richard Feynman explain how a magnet attracts another? Absolutely not. He has no clue whatsoever. Talks about electrons spinning. So what if they spin? If you have two magnets and they're spinning here and spinning here, right? The electrons. So how does that produce attraction? The fact that they're spinning, each one in its own magnet. So again, the fact that they spin doesn't tell us anything about the mechanism of attraction. And of course, the only way to figure that out is figuring out, making an assumption about what physical entities are in that region that we cannot see or touch. And there's no experiment you can run for that, no math. Make an assumption. You make an assumption about what could be in there, then you explain the mechanism. That's the way it works in physics. Okay? And just in case, here's the bot, okay, the AI bot. And they ask them the same question. When two magnets are brought close together, their magnetic fields interact. The north pole of one magnet will attract the north pole, the south pole of the other magnet. That's all it is. North attracts south. That's all they have. This attraction occurs because the magnetic field lines from north pole of one magnet enter the south pole of the other. So you have these field lines, which they say are inexistent, the lines of force. And so they enter. So what's entering? Field lines, which they say are just abstractions. So they have these field lines entering. Okay, so they enter. And how does that produce attraction? The fact that they enter, from one magnet to the other. Okay? And so they haven't explained by saying the field lines enter or the electrons spin or north attracts south. None of those are explanations. None of those are mechanisms. Okay? In summary, the attraction between magnets is a result of what? Their magnetic fields interacting. Fields cannot interact because fields are concepts. So you got to identify the object if you want to talk about, the mechanism of how two magnets come together. You cannot do it by saying fields interact. Fields are numbers, concepts. You can't say these numbers interacted. Okay? And the alignment of magnetic domains, again, the fact that they're aligned does not tell us anything about the mechanism of attraction. So what if they're aligned? How does the alignment produce attraction? That's what you got to explain. And they say, all these atoms are aligned within this magnet. Yeah, and so what? What does that tell us? Okay, so in order to understand some of this stuff, you need to find out what a mechanism is. A lot of these people don't even understand what a mechanism is. So they asked me for a mechanism. I showed them 100 times already, and they still, like this fellow said, you haven't explained it. I haven't explained it. I don't know what part you didn't understand. And so the problem is these people don't know what a mechanism is. They've been bombarded so much with concepts, with abstract mathematical idiotic concepts, never defined. And so they use these words. They use words like field and force and time and mass. And when you talk about objects, they say, what are you talking about? Again, half gun will travel. They don't understand what a gun is. They know what a mass is, but they don't understand what a gun is. You say, look, the guy shot him with a gun. What are you talking about? Oh, you mean a mass. He carried a mass. And the bullets, I guess, are tiny masses or what is it? Charges. So this is the problem. The problem, these people don't know how to talk. It's a semantic issue. They're trying to give a physical interpretation, and they bring in abstractions. That's where the problem is, okay? So they can't give you a physical interpretation, but they think they got one. They say, oh, I understood. What did you understand? That, an abstraction moved through the air? That's where the problem is. And so here, let's go easy on them. Let's go very slowly. This is a pulley. It's called a pulley, okay? And so what we want to explain, or someone asks, how is it that the box went up? That's the only question. Look how simple it is. A question of physics. Why or how, what caused the box to go up? Very simple thing. And so we say, look, there's a rope tied around this wheel. We call it a pulley. And we pull on the rope and the box goes up. That's how you would explain it to a 5-year-old. You don't need to know weight. You don't need to know energy. You don't need to know mass. You don't need any of those terms, time, none of that force, nothing. All you need is to say, look, a rope pulled the box upwards. That's the explanation in physics. Okay, that's how you would explain it to a baby. And so they don't understand that because they start asking things like, you need to pull on the rope. Yeah, I pulled it with my hands. And what pulled on your hand? Well, it was my wrist. And what pulled on your wrist? Well, it was my elbow and then my shoulder. And so they always keep asking why this, why that. Questions that have nothing to do with the original question. The only question we want to answer is, why did the box go up? And it was pulled by a rope that went around a little wheel. That's why the box went up. That's where it stops. You got the mechanism. Now, the other guy now has to explain why the box went up if he's got a different theory. But that is the theory, for a pulley. And a lot of people don't understand that. Lots of people. And they get, especially devil's advocates. And so here we're going to explain the mechanism of attraction between two magnets. I'm going to explain the mechanism, okay? And you'll see what kind of questions these people ask you. They say, well, where did that come from? And, when were you born? And, they ask questions got nothing to do with the question we're trying to answer. So here it is, okay? This is the mechanism of how one magnet attracts another. We're just going to look at a mechanism and see if you can understand what a mechanism is, okay? And here it is, the one on the top, okay? We have two guys, Axel and Rod, and they're spinning their ropes. They're skipping, right? And as you can see, the rope of the blue guy, right, Rod, goes up while the other one comes down. And when they meet, there's an attraction. It goes like this. There's a clamping there kind of thing, and constantly they're interfering with each other. So there's a pull there, okay? But if we turn Rod around, right, the blue guy, you can see now the ropes are clashing. And now they're going to push each other away. So whereas in the first one, you have one coming up and clamping into the other one and pulling, on the second one, you have them clashing against each other and pushing each other away. That's a mechanism. It's called a mechanism. And these people say, well, where did you get the ropes? What are the ropes made out of? Irrelevant. I explained the mechanism. Okay? And all these people who use ether, that's what you got to do. Explain with your stupid ether, right? Show me with your ether a mechanism. I just want to see a mechanism. Don't explain it to me. Illustrate it, just like I illustrated there. I illustrated a mechanism. The mechanism of attraction, a mechanism of repulsion. It matches exactly what happens with two magnets. You put them, north to south, right? And they attract. And you put north to north or south to south, and they repel. There you have it. And for that, you have to turn it 180 degrees. And there you have it. Okay? So I showed you a mechanism that matches what we see with magnets. You show me now with your ether, with your space-time, with your energy, with your mass, whatever you want to use, charge, force, field, any word you want to put in there, I don't care. You got to illustrate it. We want to see a mechanism. We want to see a physical mechanism. We want to see a mediator in that region. I need to know what mediator you're going to put in there, physical mediator. It's got to have shape. We got to be able to see it. Then you can explain it in the background. But first of all, show us a picture of what you propose. That's the way it works in physics for physical interpretations. Okay, so there you have the mechanism. Okay, and here's the mechanism, a little more detail maybe. Yeah, okay. This is what we're saying. We're saying that two magnets are attracted to each other because you have these threads that go around. Okay, and the closer they are to each other, the two magnets, the more threads that intervene. And that's why there's an acceleration of one magnet towards another. We don't divide a magnet north and south. We divide it in top and bottom because the top goes counterclockwise to the one on the bottom, or vice versa. depending on how you have the magnet. Okay, so there's your north-south, and here are two magnets. That's why they attract, because these things are, you can see the threads that are swinging around. They, more and more of them, you know, as the magnets get closer to each other, they're swinging, they're interfering with each other. They're causing that clamping, okay? And if you put them the other way around, they push each other away. And here, let me show you that, okay? Again, to complete the mechanism. Here are the two mechanisms, okay? You have, what is this? North, south versus south, or north versus north. It doesn't really matter for repulsion. Here you have attraction, okay? Again, clamping, okay? You turn it around in this direction, nothing changes. There's still attraction. Why? Because you can see that nothing changed as far as the clockwise or counterclockwise direction of the threads. But when you put north against north or south against south, now they're clashing and pushing each other away. Look at it one more time. Here it is. Okay, this is the mechanism of attraction. Here it goes. We start with attraction. Here it is. Okay, one's going clockwise, the other one's going clockwise as well. They're both going clockwise. They're doing this. Okay, that way. Okay, so they're clamping, catching onto the other. Okay, and if you turn it sideways, no change. You will see the same clockwise and clockwise. But when you put clockwise against counterclockwise, that's when you have push. And, you know, the bottom line on this is that Mother Nature does not understand positive, negative, does not understand North Pole, South Pole, doesn't understand any of that nonsense. What Mother Nature understands is clockwise and counterclockwise. That is physics. Okay? With that.